Cool. So we're going to start 15 to 20 minutes talking about some math for my spline library that I recently did. And then we're going to use it to improve the Futurama tubes that we worked on a few weeks ago. And let's see. So first I'll demonstrate what I worked on. So okay, so this orange spline here, this is kind of the default output of my CatRom spline library. And if we sort of exaggerate the curvature here a little bit, it's just a little bit in the way. But you'll see when there's high curvature, the points kind of get clustered together. And when there's low curvature, like over here, they're very spread out. And that doesn't look very good. So what we want is to be able to space the points equidistantly. And that's what this purple version is here. So this is the new version of the math. And if you look, even if we sort of try to force some higher curvature, the points are still equally spaced. So I guess before we discuss that, I think so there's two things to the update. The first thing I worked on was those equidistant points, and the second thing I worked on was improving the arc length calculation. And I think that we should talk about that first before we get to the equidistant points. So the arc length calculation is just 2 points along the curve, and we want to know the length between them. Okay, so the first thing I said we'll talk about is arc length. Oops. Uh-oh. I would hope this wouldn't happen. All right, we're good. Actually, before I do that, I should probably discuss really what the type of curve that we're talking about here. So the CatRom spline, this is what's called a parametric function. So let's do that first. So the CatRom spline is a parametric function of the form r of t is equal to x of t, y of t, and z of t. So what these right, these oh no, might actually have to move to OneNote for this. Okay, that seems to be working. All right, so these angle brackets just mean that it's parametric. So when I say parametric is that it's vector valued. So the input to this function is t. So t is the one input, and then what we get. Okay.
Told you today was a cursed technical day.
All right. So where were we? So we have our r of t function. Oh, and I think I forgot to also write the little arrow above the r means it's vector valued. So meaning the t is our input, that's one input, and then we have three outputs. Right. And so each of these x of t, y, and t of z of t, those are individual functions. So we combine them together and we get a three-dimensional curve. So something which are axes x, y, and z, then we get some curve like this. And at the start of the curve, we're going to call this r of 0. And at the end of the curve, we have r of 1. So this curve is defined on the interval 0 to 1. Right. So then we wanted to discuss the arc length. So your first inclination might be something like distance formula. So say, oh my God, it's stuck. Something like the magnitude between like r of b and r of a as a length. But what that actually gets is not exactly the arc length. That just gets sort of like a length between 2 points along the curve. So what we actually want here instead is maybe that's a bad color, but the length along the curve. And an intuitive way to do that is maybe we do what we did here with the blue, but we do a lot of them. So so if we want the arc length here, we do one line and then another line and another line, and we sum those up and we get a decent approximation of what the arc length is. Maddie, do you have a particular question? Okay. I guess I'll continue then. Right. So we're going to do a lot of. Oh no, it is stuck. Okay. So we're going to do an approximation of the arc length L, and we're going to sum over a bunch of these distances. So something like this, where we're summing over these x values are just points along the curve, and maybe j will 0 to n points. And so that gives a decent approximation. So actually, I should have written this as an approximation. Uh, okay, I think OneNote just crashed. Should have used Metaboard for this. Very good. Okay, so this is an approximation, whereas if we take the limit as j goes to infinity, so we do a bunch of these distances between points, then we'll actually get an equality. Yeah. And this is equivalent to just doing an integral. Okay, this is just not going to work well. I think I'll just show you what I had pre-written in my notes. So this is the approximation that we have of all these little green lines, and then if we do a bunch of those green lines, we actually get an equality, which is equal to an integral. And this integral specifically is the magnitude of the derivative of the function, which is written out explicitly here. Right. And so this is nice. We have a form to calculate the arc length, but the issue is that there's no closed form solution for this integral. So each of these x prime, y prime, z prime, those are cubic polynomials, and we can square them and add them, but we still can't integrate it because of this square root here. So instead, what we have to do is do a numerical integration, which is just approximating it using some approximating method. So actually, this might be working. So we'll try this. So numerical integration, also called in the one-dimensional case, is also called quadrature, just as a search term if you want to learn more about this. And the idea is that we have this integral from a to b, and just kind of in the general case of any function, we want to approximate this value. So in our case, this function that we're approximating is the magnitude of r prime of t. And so a natural way to do this, if we have this function, is to split it up into rectangles. And if you've learned calculus, this is just a Riemann sum. That's what we call it. So we draw these rectangles beneath the curve, and we can, instead of finding the area beneath the function, we just calculate the area of the rectangles, and it's a decent approximation of the function. And the approximation actually gets better and better the more rectangles we add. So the rectangle approach, that's one way to do numerical integration. Another way is called the trapezoidal rule. So instead of using rectangles, we use trapezoids. And this is a bit better. So this would look something like, okay, well, maybe my function isn't drawn well here, but these aren't actually rectangles, these are trapezoids. Trapezoids, that's one way to do it. We can also go into polynomials. So another estimation we can do, maybe I'll exaggerate it a bit here. So we can split our function up into different intervals. And on each interval, we'll estimate the function with, let's say, oh my god, a quadratic polynomial. Say, so we have one quadratic here on this interval, and then on this interval we have a quadratic, and then here we estimate it with a parabola. And so this is called Simpson's rule. And the idea behind using polynomials for this is that polynomials are quite easy to integrate. We we have a way of integrating polynomials. So if we estimate our function with polynomials and then we integrate the polynomials instead of the function, we can get a decent approximation of the integral. And I had more to say, but I'm actually taking up some time here. Uh, so I think we'll go into the next thing, which is the Arclength parameterization. So the first thing we talked about was finding the arc length of the curve, and then we're going to use that in the Arclength parameterization. And so this was the thing I was talking about, where we get these clustering of points along our curve. So what we want to do is, so right now we have the orange, and we want to get to the purple, where everything is equidistant. And this is going to use an arc length calculation. It's unfortunate because I've used my notes for this. My notes are up here. Okay, right. So in this setup of the problem, so we have our curve, and if we sample some points on our curve, like I said, we get some clustering by the higher curvature here, and then it thins out where there's less curvature. And what we actually want to do is get it into some form where everything is equidistant. We're not necessarily equidistant, but we want to be able to say, like, I want a point that's 50% of the way along this line, and it'll do that by arc length. And that allows us to get equidistant points. So really what we're doing is we're finding some function where we're given some input s, maybe we're not, okay, s, and we want to map it to some input t. So s is awful. Okay, I'll just show you my notes. All right, so we're given some input s, and that's a percent arc length. So we say we want the point that's 10% of the way along the curve. And then we say, okay, what's the t value that we can plug into our function r to get that point? And if you want to describe this mathematically, it's an integral. So s really is, we want some length. So s is the length that we want along the curve. And then we want to integrate, maybe I should, I don't think I think that's right. Yeah, so we want to ask, like, what is some percent of the way along the curve? And then we want the actual input, I guess. Oh, so this t is that x. So we're like, we want to find the point, right? So we want to integrate up to the point where we get this L, I guess is what I'm trying to say. So in the previously, when we did a numerical integration, we knew the bounds and we were solving for the length, but now we know the length and we want to solve for the bounds. So we know that the length is s, and we want to solve for the x such that this integral equals L. And I said
the differential being s is just an unfortunate clash of notation, right? I mean,
yeah, I actually even realized I wrote that when I was writing my notes and just didn't fix it. But yeah. Okay, I can't erase it. But
wow. Yeah, this is an ad for Metaboard. Look how crap all this other software is.
Yeah. So I had said previously that we don't have a way of actually integrating this function, the magnitude of r prime. But say we suppose we do, and we'll call it big F. Then by the fundamental theorem of calculus, this integral is f of x minus f of a. And f of a, this is really just an arc length from a to a, or an integral from a to a, so that's just 0. So that term goes to 0, and we're left with f of x. And then if we just move L to the right side, we get 0 equals f of x minus L. And what's nice about this form is that this is in the form of a root finding problem. So when I say root finding problem, I mean, okay, I'm just not going to draw it, but I mean a function. We have a function. We want to find where it crosses the x-axis. So in that case, we're trying to find the x value for which this function is equal to 0. And okay, this diagram won't mean much if I can't draw it. Uh, okay, we'll try here. So we have a function, and it looks something like this, and it crosses the x-axis here, and we want to find that point. So we'll start with some initial guess. We'll call this alpha naught, let's say. And alpha naught evaluates the function, so f of alpha naught is there. And then what we do is we find the tangent. So the tangent line is going to look something like this. And then we find, okay, one note's not going to work either. But we find where the tangent line crosses the x-axis. Okay. Maybe I could look up a visual online real quick. But basically, the tangent line crosses the x-axis, and that becomes our new alpha. So that'll be alpha 1. We find f of alpha 1. That'll have a tangent. And eventually what you see is if you repeat this process, we get closer and closer to the real root. So I'm sorry I couldn't have done better justice to this, but maybe next time we'll actually use Metaboard. So I hope through my ramblings that at least made a little bit of sense of how we calculate a numerical integration for the arc length. And
I think that was clear even despite the technical issues.
Okay. All right. So that was the math I wanted to cover for CatRom. That is in the latest version of the library, version 0.5. And so now we're going to use that to continue working on our pneumatic tubes. And with the pneumatic tubes, this is what I think we should work on. So the first thing is we used unions for the tubes. I think we should swap those out for meshes so that we're not doing live unions. And then we want to refactor it into a usable API. And then the last thing is we want to be able to load tubes from the data store for pockets. So let's open that, and I'll just play it so we all remember what we worked on the first time. Right. So we have these points, and we use CatRom to connect the points using a spline, and then we have these tubes, and I should walk through the tubes. Cool. So that is what we worked on last few weeks ago.
What's the dire need to get rid of the CSG? There's just a general fear of doing that live, or
Yeah. So if I generate this, you'll see it like takes a few seconds to generate, and that's not like an effect. That's just how long it actually takes for the unions to compute. And then they also just don't look as good. So you can see these like triangles. Yeah. So in preparation for this, I actually went back into Blender and I created more mesh tubes. Because if you recall, I had made some meshes last time, but they had no geometry. Like you couldn't walk inside of them. So I recreated the tubes, and this time you can actually walk inside of them. So we're going to replace the unions with these meshes.
yeah, that looks much better. Well, not with all the colors, but before that it did.
Yeah, that's the decomposition geometry. Okay, so this is the code where we create the tubes. And let's see. So this is creating some parts, and then we're creating a negation. I think we can just chuck most of this out. All right, so the first thing is we want access to our meshes. So put this tube inside of here. And then we'll have a reference to the tube. And then instead of creating this part, we'll just create a clone of that tube mesh. And let me make sure I anchored it and all that. Okay, can collide, anchored, we're good. And then most of this can go. Okay, so we'll probably need this. So tube.size. What is the long end of the mesh? So we're going to want to grow the Y. So that's going to be this one. And then the C-frame, we'll just use the same C-frame and then we'll probably have to adjust it. And then I think the rest of this can go. We don't need the negation. We don't need subtract, right? So this can all go. We'll just parent it to workspace. And then let's run that and see what we get. Okay, we're a bit off. So specifically, we need to rotate about, what is that, the Z-axis. We'll just fudge these C-frames. I think actually what I might have to do is just delete the rotation we had for the original union. Okay, no, that was wrong too. We'll just rotate it on some axis until it works.
What was the rotation originally on? The Z?
It was originally around the Y-axis.
Well, that swapped with X, so... Didn't it? The long way was X before, now it's Y.
Oh, that's right, yeah. I can't, like, in my head in real time, I can't think about what axis that should be. But that seemed to work.
Lucky guess, I think, for me, but yeah.
I mean, I tried all of them.
Yeah, that's usually how I do things too.
Yeah. Okay, so that looks a lot better. Something else I was thinking about we should try to tackle, or at least think about, is these weird gaps. But I think the solution to that is to just not let that happen.
I guess I'm now confused about, we didn't seem to have those holes at the corners before, but there was no reason why we shouldn't. So why did it look better before?
Oh no, we did have those holes.
Oh really? Okay.
Yeah, I guess I probably should have shown that.
Yeah, that's fine. I guess I just missed them. Maybe you've updated the CatRom library, is that right?
Yeah, oh, good point.
So before, maybe there were more tubes around the corners, and that's actually desirable.
Oh, so actually, we haven't changed the methods yet. So if we want to use the new methods that do the Arclength parameterisation, we add the uniform keyword. So I'll show you what that looks like. So and then see solve uniform. If I run it now, we should see that every tube has the same length. I think it looks better that way. But no, our problems are still not fixed, unfortunately.
Maybe, I mean, it could be quite complicated to get elbow joints working. Maybe for the moment we just say it's the user's problem if they make curvature too high.
Yeah. I mean, I think you could connect them with a sphere, but then the sphere isn't hollow. Yeah, it's probably just not a big thing to worry about. Oh, sorry, what'd you say?
Could just be like a cosmetic sphere that doesn't collide, but just goes up the hole.
True. Yeah, we could actually try that.
But then when you go through the tube, you'll be scared every time you get to a joint. You're going to smash into this sphere.
Thought you'd be scared because you've been...
Yeah, if you hop into the giant pneumatic tube, you'll probably feel this. So.
Right, okay, well, I guess I'll give that a go and see how that looks. Yeah. Let's see if that works. Oh, they're not. Uh, right. Hey, that actually looks really good. I mean, you can tell that there's a ball in there, but I think it makes up for the fact that, like, now there's no gaps. So the last thing I'll do is I'll just fix the studs. All right, yeah, I'd say that looks pretty good. And then, okay, the next thing on our agenda is to refactor into a API. Um, Probably isn't a terribly interesting thing to watch, but I think what I want to do is put into some module script, and you can say, uh, here are these points, give me back a tube, or here are these parts and give me back a tube. Uh, and then I think eventually we want to maybe package this up into something that can be distributed on GitHub. But for now, I think it can be a little bit messy. So let's create a module script and call it tubes. And some functions that we want out of this module script. So maybe we'll do tubes.from points, and we'll do tubes.from parts. And then elsewhere we'll use these. So elsewhere we'll do the collection service stuff of collecting the parts that are marked as tubes and then calling this function. And then let's also steal some math that we have. So we'll take this function. By the way, if you joined recently, unfortunately you've missed the math, but maybe hang around for the code. And then I think we can worry about this later. Oh, we'll want some of this too. So we'll do, right, okay, I'll just copy this in. So the first thing, I guess we should also require the library. And then the first thing we do is we create a spline out of the points. And then we should also probably be able to define how many tubes we want. Maybe we'll default to 40 or yeah, we put 40 here. Or maybe actually what we want to define is a tube density of like number of tubes per studs. Oh, that's a good question, Maddie. So Maddie asks, do the balls disappear if you use glass instead of plastic? That actually could work. So we'll make the tube glass. And then, Maddie, does the ball also have to be glass?
What
Not
do you
sure.
mean by
Okay.
disappear? Like, why would you want it to disappear?
Um, wow, that actually worked. So it's because glass occludes things that are translucent behind it.
Um,
So actually, I have a cool little demo. I don't know if it's worth pulling it up right here. but it exploits this trick to do kind of targeted occluding of parts. So like here, where it looks like we're seeing through the sand, but actually these are just glass parts on top, and the glass parts occlude what's behind it. Okay, so yeah, that worked really great. All right, back to this. So we define tube density, we have our spline, and so the number of tubes is going to be, so it's going to be the length of the spline times the tube density. And then we're going to calculate some points. All right, so we have this for loop over the number of tubes, and then we're going to solve for the, right, okay, so this was something we did last time. These solve uniform positions, we're actually doing 2 in one frame, or per loop, but we can actually just do 1 and then reuse it for the next one, because this solve does kind of like the left side of an interval, and then this solve does the right side of an interval, but then the right side gets reused as the left side for the next interval. So we can actually reuse. Right, so then we're going to connect our tubes. So we're going to connect the previous position and then the position we just calculated, and then we're also going to pass in the tube radius. Why is that yelling at me? I guess, so one thing we need is, we need this tube object. Unknown global connect, did I spell that wrong? Oh, I did. And then I also don't have a tube radius. So actually tube radius might be something that you want to pass into the function. And what did we have for that? We had 3. And then for the default tube, what is it, density? Do 10. Maybe density's a bad name for that. I feel like that could imply something else. I spelled that wrong. All right, we'll go with it. And what else? So we have tube radius. I'm going to pass in the tube radius. And then also the rings, right? So we're also going to need the ring mesh. So that should work. And then let's not recalculate. Oh, actually, we do need to recalculate this. So we'll do. I'm in the wrong script. I mean to be in this one. Right, that. And good. So that should work. Let's test that out. So we're going to want some script to collect our points and then call our API that we've just written. that we actually want tubes. Cool, let's see how that goes. Oh god. I think I was about to crash. Alright, so for one, I didn't pass in a radius, but it should fall back to the default radius we gave it. Maybe the number of tubes was like really high. Let's see what that was.
Dan, was that a goose or like a desk chair?
It was two geese outside my window. All the birds on the property. Whoa, that is beautiful.
I know what the problem is. I didn't pass on the previous position.
I want this version of the code though.
Something is okay. We're starting. Oh, it's just using them unordered. I forgot that I ordered the points by name, but that's kind of on an implementation basis of if you actually want to do that. But we can, yeah. So it'll be part.name. No, this I is going to be to number part.name. So that should give us an order. Or I didn't. I did name them. Part.name should be number to number. I should just copy and paste the code that we wrote last time.
Is it entrance?
Oh, that's right. Yeah, entrance is screwing it up. I can't remember how we did that. Tube tagged. Oh, here it is. Tube. Oh, right. Okay, that works. Oh, and then we've also forgotten the last one. I think I have an off by one in this function. I have an n minus 2. I don't remember why that worked the last time, but I think that's our problem. Yeah, okay. I'm not sure why our old code didn't use that last point, or maybe it was doing something else.
What
Something
does the
doesn't look right
connection
about
look
this.
like at the entrance?
Oh, the entrance? Oh, sorry, I missed the question.
Yeah, I was just curious what it looked like. Cause, is there any way we can connect that up better?
Yeah, so right now we're not doing anything about the entrance, but I think what we'll do is we'll consider the first point to be the top of the entrance. And then from there, it'll connect to whatever the first user-defined point is.
All right, so that wasn't the code's fault. It was just our fault for not positioning the entrance properly where the first point is.
Right. Actually, that is a good consideration of how we're going to handle the entrance.
Like,
And
because it could just
maybe,
be the user, not the API itself.
yeah, we want to make this as easy as possible. I think what we could do is, in addition to passing in a list of points, you also pass in an entrance C-frame, and this would be the C-frame of, well, the entrance. I think that could work. And then, so you'll place the point on the ground, and then if we change the pivot to the ground, then our entrance should be positioned correctly. So let's add that. So we'll have an entrance, and I think this is a model. So where did I put this? Right, this model. And we want its pivot to be in the ground. So we'll move that down. That looks pretty exact. Okay. So we'll take this guy, put it in tubes, and then we'll clone it. And then we'll do pivot to entrance. Seed. Oh, call it the entrance C-frame. Oh, I didn't give it an entrance C-frame.
What is this amazing thing you have of putting top, left, forward, front, and back on parts?
Oh yeah, that's great. So this is a plugin called Studio Tweaks, and it has a number of things here in this menu, but that's one of them. Yeah.
Is that Windows only?
Is it what?
Is it Windows only?
Oh no, it's a Roblox plugin.
Oh, cool.
Yeah.
I had to look into some like this like Roblox Studio mod manager or something, and I thought it was like Windows only.
Oh,
I guess
I
you're saying
think
it's
you're.
not other mods.
Are you talking about this mod manager?
Yeah.
Yeah, that's to like. You can edit fast flags, so you can get access to features earlier.
Uh,
I can do some other things too, like you can change out the icons in Studio. All right, so let's add an entrance. Okay, that almost worked. My entrance is rotated for one. So this entrance needs to be pivoted by pi over 2. And then the other thing was I wanted to add a position to our set of points that starts at the top of the entrance. So, all right, so we'll insert into the spline. We'll do the pivot of the entrance and then add the height of the entrance, which if I had to guess, oh, I actually remember from modeling it, it's 10 studs. Oh, I have to add it to the front. Sweet. And then also this entrance should be glass. Something else I noticed is that I used the wrong color for the joints. So I think I should have used teal instead of toothpaste. Actually, that still doesn't look right because that's plastic. I suppose I never set. I don't know if I ever made these glass. There it is. Yeah, okay, I forgot to do that. All right, that seems to work. So that's our from points method. Oh, wait, Billy, did I miss you say something?
I was just saying it looks really good now.
Oh, yeah. Cool. And then from parts is going to be just about the same thing, but instead of um, actually, we could almost extract this into two different methods, or one method, I mean. So do a create tube. Or no, what am I saying? So we can call from points from parts, and that will make our lives easier. So this is really just a helper method, just for convenience. And then from this, we'll call tubes.from points. Right. I think that's pretty good.
So when you call from parts, they need to be like in order.
Oh, yeah, yeah, that's a good point. Um, I don't, I think that should be like on the burden of the caller,
Yeah.
how they want to do that.
So let's go back to the like calling script and see how you can change it to use from parts.
Yeah, it's almost less convenient to use the from parts.
Because you have to reorder the parts anyway.
Yeah, seems like we almost don't even need this.
It would just amount to the same thing of just uh, making a second parts array instead of a parts array,
Yeah, so
inserting them in that order.
I'd say we'll delete that. Uh, I guess yeah, we'll leave it as from points. Okay. Let me check with the original script to see if I missed anything. So we have our connection, create the spline. Oh, and then this was, all right, so we should set up a touched event. So let's copy this over. So here, I think kind of another convenience thing, we should probably automatically create the touch part. So I deleted it, but I mean just like a part inside of here that you touch.
Sorry to interrupt, Ethan. I'm going to have to jump into disruption in about 6 minutes, but I think you should continue. It would be a shame to wrap this up prematurely. So the recording will continue. It's just I'll have to jump out.
Good. Right. And then also we have, I forgot about the remote event. This guy. So that tells a player the tube. So we'll also get that. I keep seeing these random errors. What are these coming from? Shadows, line 77. I don't even know what that was supposed to represent. I think it was a model. Okay, we'll deal with that soon. Right, so we touch the part, we get the player that touched it. So if they're a player and we haven't seen them in the past 5 seconds, then we'll add them to the debounce table, and then we need to tell them that they've touched a tube, and then on the client we handle the actual interpolating along the tube. So, what's the most efficient way to send the tube data to the player? Because there won't necessarily be parts that the player owns on their side. We might just have to send all of the positions of the spline.
How come you do the touched event on the server and tell the player about it instead of like, why not do it in a local script so that
Well, that's a
the
good point.
player detects the touched event?
Yeah, I guess you don't need to, but somehow the player needs to know what the spline is.
Right. Which stuff is or isn't replicated on the client side?
Um,
Like they have all the physical parts that appear there.
yeah, they have.
What about the points that define the spline originally?
All right, so those won't necessarily be parts because you could just call this from points method with a list of points.
How is it working at the moment? Are those parts just still there when you hit play?
Yeah, so at the moment, the client knows about these parts. And so there was no custom replication needed because it knows their positions.
Uh,
But like I said, that they won't necessarily be there. I think for now, we'll just send a list of points, and maybe there's a more clever way to do that. So the points we'll just send here.
can you just do the whole thing client-sided?
I suppose you could. Well, okay, so there's some cases where you wouldn't want to, because, say for instance, in a pocket, you want to be able to save a spline and then load it. So you're gonna have to load it from the data store on the server.
Mm.
But maybe the server just passes it to the client. Maybe you replicate it through like uh, vector 3 values, like value objects. You're right. It does make sense to move this to the client.
But does that like ruin like collisions or something between? I suppose if everyone is making that the tubes in the same spot, then physics will just work out. Is that like an issue?
Yeah. I don't think it'll be an issue of like not being synced between clients. Right. Okay. So here's what I'm thinking. So in some cases, maybe we can just use collection service. And like, so in some cases, the points will already exist in the world. And the client will see those through collection service and then create the tubes from that. So we can create the tubes in that case on the client. And then on the case for the server, what we can do is we can say in like replicated storage, we can tag some folder, and then in the folder we have some vector 3 values, and each of these values is a point. So then when you load in, you can find these. The client can find those. Okay, so in that case, if we're moving to the client, we can change some of this touch logic. So we'll say, well, maybe this is still the best way to do this. I guess that's all right. And then just for the sake of not touching the same tube multiple times, we'll just keep one global touch debounce. So we'll set touch debounce to true, and then we'll task.delay at 5 seconds, and then set it to false. Or actually, that's an awful name. We'll just say can touch tube. All right, so then here we don't have to fire a client. Instead, what we want to do is interpolate the client. It seems like it shouldn't be the job of this module. I guess it's fine. Right, so then we'll go to our client code, and then the client is where we do the sliding. Actually, that's a better name. Right. So we disable the character's controls, we anchor the root part, and then, okay. Sure, so we'll just copy this. So to get the controls, we do, I guess we need the character and the root part, okay. Controls disable, root part anchored. Need run service.
Well, does it work if I push a ghost into one of the tube entrances?
That's actually a good use case. Maybe it shouldn't be slide character.
Like you might want to just push random objects.
Yeah. I wonder if we don't do this here and we just like we let the user decide what to do with the touched event, but then we give certain functions for sliding a character or sliding actually you don't even need to slide a character, you can really just slide a part. And that part can be the root part.
But is that replicated in the same way from client to server if it's not the humanoid root part?
Oh, that's a good point. This only works if you have physics ownership.
Right. Seems a bit
It was my
complicated.
ghost.
Yeah, I mean, it would have to be done on the server if it's supposed to be something general that could handle things other than players. And then you have to do both, right? Because you want it to be done on the client side on the player because it'll be smoother than having the server animate their position.
Yeah. So I guess that's the benefit of writing a generic API is that we can call this on both the client and the server.
Yeah,
And
can you just
then
like pass in like a callback function to call on the touched event, and then you can just design
oh
things to happen.
yeah, so you're saying like a callback?
Yeah.
Yeah. Right. And then
Or it would just be like all of that logic moves.
right.
But is there any of that logic that's internal to this module that you don't have access to? Spline or something.
I mean like the control stuff that has to get moved. So we want to keep this inside of the module, but then have this outside. I don't even think we need a callback. I think just we can return the touch part maybe. I don't know. What do you think of that?
What are you returning, sorry?
Just return the touch part, and then whatever calls it can use the touch part and connect to it.
And the function that you connect to that outside of this module would still make use of functions like slide character or slide. It would just decide how to do it.
Yeah. So we can let that function decide. You're right. Yeah, like which one it uses, slide part versus slide character.
Mm. Well, like in general, it could just be a function that like uh, you can call it at any frame, and it tells you the position where like whatever it is you're moving along the tubes where it should be, and then it's your job to put your part.
Oh, yeah. So you let the module do this run service stuff for you, and then it just spits back out the C frame.
Uh, oh yeah, so, well, I guess it would be like you could do it as like the callback that you give it is a function that takes in a position and does something with that position.
Oh, okay. Yeah, I like that. I think that makes a lot of sense. Well, that's I guess that shouldn't be, because sometimes we want to touch the event, but sometimes we don't. Like if we just wanted to slide a ghost or something. So that should also be the job of the calling function.
What should be?
Well, we might not even want to have the dot touched. Or like there might be different logic. Say if it's a ghost, then this wouldn't capture a ghost. This would just capture a player. Or we could just loosen the constraint. We can just say that it's a model with a humanoid.
Like, what if the what the this module just provides the uh, inside the module you don't do any like triggered logic. You just like the code that's calling this module can decide to start that whole run service thing and give it the callback to tell it what to do when it gets to a new position.
Right. Okay. Yeah. I think I only understood like half of what you said earlier, but I think I get it. So here we'll just return the touch part, and then so this will be a method of the module. Yeah. And then we'll give it the spline. So I guess this needs to kick back out the spline too. And then we can remove any of this logic. And then we just call, all right, we need the callback. And then we'll do the callback and we'll give it the C frame.
Mhm.
And say, for instance, if like the player dies while this is happening, I think the callback should spit out like a return value, like a success. And if it's false, then we should stop the slide. Or if like the player manually cancels it, maybe. Okay, it doesn't like my types, whatever. And then, okay, we also don't need this angles then.
I mean, it's not a function anymore. You need to write
Oh,
function instead of local.
that's right.
And it's not a local function, right? It's
Yeah,
just function because it's tube stuff.
right. Okay. Yeah, and then because this will yield, so when the yield is over, then the calling function can do this controls thing. Okay, I think that's good. So then we can remove anything that has to do with this. And see, we need run service. We don't need the local player. Cool. Okay, I think that's pretty clean. Still works. Yeah, okay. So then I think we'll end this. I'll just try to use the module to have the character touch the part. And I think we'll end it there. So I'll just disable this. We'll start fresh. And then we'll move this to the client. And then we do tubes.slide, and we want the spline. Oh, and then we pass the callback function, which gives it a C frame, and then we do the root part.C frame. And then at the end, we do controls enable root part.
You were gonna return like a success value.
That's right. I guess if the yeah, we should also need a humanoid then. And then also this needs to move to starter player. It's definitely touched. Success. Is there no root part? Oh, I spelled it wrong. Oh my god.
Other spheres in the way? Did you turn off cancel light?
Oh, maybe? Yeah, they should be false. I think one issue is that there's no debounce, so it might be like 10 splines are trying to take control of my character at the same time. Yeah, this is annoying. That just didn't work at all. See if we're getting anything from the callback. One time. Oh. There we go.
Nice.
Almost. I think it was rotated. I don't even know which axis it should be. But yeah, pretty much got it. I think I'm happy with the API and appreciate the help, Billy.
No worries.